Hello everyone, so welcome back to my channel again, Intelligent Learners. In this video, we are going to discuss about a theorem, the third theorem of a circle, which says that angle in the same segment, they are equal to each other. Now we are going to prove this theorem by using the previous theorem, which says that angle made by an arc at the center is double the angle made by the arc at the circumference of circle, right? So to understand this theorem, we should know what is the segment in a circle, which is very important. And because we are collaborating the previous theorem to understand this theorem, so kindly see the proof. I have not done the proper proving, but I just told you that how we are using the previous theorem to prove this theorem, right? So yeah, let's start with the video, everyone. Three angles in the same segment are equal. To understand this theorem, we should understand what is the segment in a circle, what are the angles that we are making within the same segment, and how these angles are equal. So three things are important for this. So to understand, let's make a circle first of all. So when I will draw the circle, so this is my circle. In that circle, a very important thing that I'm going to draw is the chord. Now, first of all, everyone know what is a chord? A chord is a line segment. Line segment which touches the circle at 2 points. So this is the point A, this is the point B. So this chord, this line is touching the circle at 2 points, C and B. Now, what is the segment? Very important. What is the segment? Segment is an area which is covered by the chord and this arc of the circle. The part of the circumference is called as the arc of the circle. So area covered by this. So what we will talk about, we are talking about this area. So this is called as the segment. Now you will say, ma'am, this is the chord AB and this is also the arc. So yes, this is also the segment. So what is the difference between the two segments? That this is my minor segment. This area is called as the minor segment and this area is called as the major segment, right? This area is called as the major segment. So the blue one area is the major segment, right? Now, how to clear this theorem? Now, I think the segments are clear to you. Now, we are going to make the two angles in the major segment. So, first of all, I will remove everything because I don't want this. Let's remove everything. Okay, now we want chord, that chord we want. So AB is the chord. Now what I will do, first of all, I will draw the center of the circle. So let's say this is my center. Center is O, right? Center is O. Now O is the center of the circle. After that, what we have to do, we have to draw the another chord, which is exactly little in front of the AB. So this name is the CD we have to draw. Now what we have to do, I have to join wait a minute. Circle is not exactly at the center. Let's say here it's the O. Now what we have to do, I have to just join the end points of the chords like A to B and B to C. But please remember what I have to understand, that O should not be exactly touching the chord. So O, I will make it later. So we have to do like this. And the center I am drawing it, let's say here. Okay, this is the center. So I'm not drawing, means these lines are not touching the center exactly, right? So that's why what we have to do, we have to make CD very small and AB little bigger, like that. Now what we have to do, if you will see, this is my major segment. This is my major segment. What I have to do here, I can take any two angles. Let's say I'm taking this angle, and I am taking these two angles. So these two angles are covering in the major segment only. We have to prove these two angles equal. So what is my first step? What I will do here, after completing all these things, what I will do, I will join B to O like this, and I will join O to D like this. So if you will see here, you will get an angle, which is this one. Okay, BOD. Now, to prove this theorem, we should know a very important thing that we have already discussed the previous theorem, that you know that whatever angle I am making at the center, whatever angle I am making at the center by the arc, so angle BOD is double the angle BAD. Means the angle that you are making at the center is always the double of the angle which you are making at the circumference of circle. So this angle is at the circumference. Here you are making. So BOD is double of this. Okay, this is equation first. Similarly, angle BOD is also equals to double of angle BCD, because BCD is also at the circumference. So this is also double of this BCD because they both are the circumference. Now, if I will compare these two equations, their left hand sides are equal. So if their left hand sides are equal, then their right hand sides are also equal. So I am equating equation 1 and 2. So now BAD, twice of BAD is equals to twice of BCD, 2 and 2 cancelling out. So angle BAD, that is equals to angle BCD, as simple as that. So now we have proved that angle BAD and that is equals to angle BCD. Now it's very important to understand that the line that I am making AD and CB, they are not touching the centers. Okay, that is the important point that you have to remember. So this is the way to prove that